Hello, Algebra 2 honors students. Today I am making a video from home. I did not have time to make it up to the school. It's about 8 o'clock on Sunday night, and at this point I'm a little too tired to leave the house. So you will not see my face, and that is probably a really good thing right now because I look a hot mess. But we're going to work on section 8.7, which is about simplifying radical expressions together. So here it says some properties of radicals, and it says for any real number a, if you're taking the square root and your index, and that's the important part, your index is even, then as we take this number out, we need to ensure that what was underneath the radical was positive. That's why it has the absolute value bars around it. Because remember that whenever you have an even index, if you have a negative value underneath the radical, that means that you have imaginary values. And here we are dealing with not wanting any imaginary values. So when your index is even and you're taking things out, you want to make sure that they represent a positive value. Here, if our index is odd, we don't need to worry about having an absolute value because remember, we know that with an odd index, you can have both negative and positive numbers underneath the radical sign. So if your index is odd, you really don't have to do any extra thinking. When your index is even, we're going to have to think a little bit. We're going to come across some scenarios where we'll talk this through together. So let's start with example number 1. We're going to take the square root of 49 x squared, y to the 5th, z to the 6th. Okay, so I'm going to write this out the long way real quick. 49 we know is going to break down into 7 times 7. X squared means we have x times x. Y to the 5th means that we're going to have 5 y's. And then z to the 6th means we have 6 z's. And all of that is underneath the radical. All right, well, our index, we don't see one, so it's understood to be a 2, so we're dealing with an even index. That also lets me know that I'm looking to put things in groups of 2, in pairs. So I have a pair of 7s. I have a pair of x's. I have 2 pairs of y's, and I have 3 pairs of z's. So I get to take out a 7, 1x, 2 y's, 3 z's, and underneath the radical, all that I'm going to have left over is a single y. All right, well, the rules that we just talked about are really important for the variables. Clearly, we have a positive 7 out here, okay? But we have to ensure that we know that x represented a positive number, and so I'm going to put the absolute value bars around that. I also need to ensure that y was a positive value, but here's what I want to draw notice to. For one, we have a y squared out here. Well, if that had been positive or negative, regardless, what happens when you square it? Turns into a positive. So this is already ensured that it's positive. But not only that, because we still have a y underneath the radical, it has to be positive because we're not allowed to have a negative under there. So I don't need to put those absolute value bars around the y's because those 2 ways that I know that it has to be positive. For the z's, I do need the absolute value bar, because if I were to raise it to the 3rd power, potentially, it could be a negative value, but I have to ensure that it is a positive value, and so the absolute value bar is the way that I'm going to do that. Now, to make this answer look maybe a little bit nicer, I will put the x and the z's together in the absolute value bar, and then put the y's behind it, just so you can kind of tell what is inside and what is outside of those absolute value bars. All right, example number 2, we are going to take the cube root of something. I'm not going to do what I did in the last problem where I wrote it all out. We're just going to talk it out. So first thing I need to do is figure out what number can I multiply by itself 3 times to get negative 27. And that answer is negative 3. All right, a to the 7th power. That means that I have 7 a's. How many groups of 3 do you think we could find in there? Hopefully you're thinking 2, and you would be right. I have 2 groups of a's. How many would be left over? 1 would be left over. So there's going to be 1 a underneath that radical. Now I think we had seen this earlier this year, but remember I kind of showed you a shortcut way. This index is 3. 3 can go into 7 2 whole times, which is why I got to take 2 a's out. But that would have left a remainder of 1, which is why there's 1 left underneath the radical. For the b's, we have 3 of them. That's perfect. That's a group of 3. So I'm going to take a b out. And then for the c's, I only have 2, which means I don't have a group at all, so they have to stay underneath the radical. Now remember, because our index is odd, we don't have to worry about those absolute value signs at all, so we are done with number 2. All right, number 3, we have again an even index. Square root of 64, that's a perfect square. We're going to take 8 out. For the c's, we have 4 of them. Remember, our index is a 2. 2 can go into 4 2 times. That means we get to take out 2 c's, and there would be no remainder, so there's going to be nothing, no c's left underneath the radical. Our index of 2, can we get any groups for d? No, because we only have 1, and we need 2 to make a group, so the d is going to stay underneath the radical. And then for the e's, 2 can go into 6 3 times, and our remainder would be 0, so there will be no e's underneath the radical. Now remember, if your index is even, this is where you want to take a look at, do I need an absolute value sign? Well, I don't need to put an absolute value sign around the c's, because if I square those c's, it's going to be positive, so it's not necessary. I do, however, need an absolute value sign around the e's, because if you were to raise something to the 3rd power, that could still potentially be negative, and we need to ensure that it is positive. So one way to think about it is like this. If your index is even and your exponent is odd, then you need an absolute value bar. That might be a little trick to making that a little bit easier. I'll say that again. If your index is even and your exponent that you've taken out is odd, that's usually an indicator that you're going to need that absolute value bar. All right, so let's take a look at number 4. We are cube rooting again. Negative 32 is not a perfect cube, but let's talk about negative 32. That would break down into negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Or you can notice that you have 5 negatives, and if you multiply 5 negative numbers, you end up with a negative number. So what if we just say, hey, we have a negative number, like almost like you have a negative sign out front, and then you have those 5 2's. So let's go ahead and let's say we take, well, let's do this. Let me make it like a negative 1 times 2 times 2 times 2. So I have a group of 2's. I also know that negative 1 is a perfect cube, so I get to take out a negative 1. So if I'm taking out both a negative 1 and a positive 2, that means I'm taking out a negative 2. And what's going to be left over underneath the radical? Those 2's right there, which are going to turn back into a 4 because I have to multiply them together. All right, let's look at our variables. The index is 3. I have 6 f's. How many do you think are going to come out? 2 get to come out. How many are going to stay inside? None, because we took them all out. G's, we have 5 of them. I can take 1 out, but that's going to leave me with 2 left over. H's, I have 2. I do not have enough to make a group, so they are going to stay underneath. And again, because my index is odd, I don't need to worry about the absolute value bars at all. All right, so moving on. Properties. This is review. This just says that if you have two radicals and their index is the same, you can multiply them together and put them underneath the same radical, or vice versa. You can take those things and break them apart into two separate radicals and they would still keep that same index. Same thing happened with a product that could happen with a quotient. So I could take this and break it up so that I have a single radical in the top and a single radical in the bottom, or if I saw that, I could put it together under one radical that has the same index. So those are old. All right, so let's see how this applies. So if we're taking a look at number 5, it says simplify. So one thing you notice is that this has a radical and this has an exponent, but let's talk about what that exponent to the 1/3 means. Remember, that means a radical, and the denominator represents your index. So what I'm gonna do to start off with is just rewrite this in the form of a radical, because I personally like both of them to look the same. Just makes it easier. All right, so obviously here I can multiply these together because they both have an index of 3. One thing I would encourage you to do is be smart. I could multiply 27 times 5, get a big number, and in a minute I'm gonna have to break that down. Or I can go ahead and break the numbers down as I know, because I know that 27 breaks down into 3 3s, and then I have the 5. So I'm putting them all underneath one radical together. Then I have an A in the front and an A to the 4th, so that gives me a total of A to the 5th. And then B cubed times B is B to the 4th, and I gotta keep that index of a 3. And now I'm gonna look and see what I can take out. Well, obviously I get to take out a 3. So I'm gonna have a 5 stay underneath the radical. I can take out one A, but I'm gonna have 2 left over underneath the radical. And for the B's, I can take 1 out, but I'm gonna be left with 1 underneath. And because my index is odd, I do not need to worry about absolute value signs. All right, let's take a look at number 6. I'm gonna, again, start it off the same way, just by rewriting this in the form of a radical. And the 2 is the index, which is good news, because in the denominator, even though an index is not written there, it is understood to be a 2. All right, so now I'm gonna do a little bit of division. So 8 divided by 4 is 2. Because these have the same index, this is understood to be a 2 and this is a 2, I can divide these. So 54 divided by 3 is 18. And then x to the 5th divided by x cubed. Remember, you keep your base, you subtract your exponents, so we're gonna end up with x squared. And now I'm gonna break down that 18. I'm gonna keep breaking my lid. So 18 breaks down into 2 times 3 times 3. So I have a pair of 3s. I'm gonna take a 3 out, but I already have a 2 out there, so I'm gonna multiply that 3 times the 2, and I get a 6. I'm also gonna take out an x, because I had a pair of them, and I'm gonna keep the 2 underneath. Now remember the tip I told you guys before. If your index is even, and the exponent that you took out is odd, which we do have odd because that's to the first power, then I know that I need my absolute value bar. All right, let's keep going. So number 7, again, I'm just gonna start by rewriting as a radical. They both have an index of 3. I'm gonna multiply these together. Again, you can just go ahead and write 3, and then the 9 breaks down into 3 times 3. Or if you prefer and you want to multiply them together and write down 27, that's fine too. I have a total of 5 R's and 6 S's. So already I see I have a group of 3's. 3 gets to come out. Let's look at the variables. R to the 5th, that means I can take 1 out but leave 2 underneath the radical. S to the 6th means that I can take 2 out and none are left underneath the radical, and because our index is odd, we don't need to worry about absolute value bars. Number 8, I'm gonna do the same thing. first rewrite so that they both have radicals. So in the denominator, my index is at 2. So since they both have the same index, I'm going to just divide those radicands. So 54 divided by 3 is 18. X squared divided by x. Remember, we're going to keep the base and subtract the exponents. We're going to do the same thing with the y's. Keep the base, subtract the exponents. We just used 18 a moment ago. That broke down into 2 times 3 times 3. So I have a pair of 3's. I also have a pair of x's, but the 2 and the y have to stay underneath the radical. And the x right here came from an even index, but this is an odd exponent. So I'm going to include the absolute value bar with that. All right, number 9, I'm going to start off the same way. Let me just rewrite above that. Square root of 64ab to the 5th. Okay, so 64 breaks down into 6 2's. And the 8 over here breaks down into 3 2's. So I currently have a total of 9 2's. Then I have 2 A's and 11 B's total. So let's see what we've got. Our index is 2, so we want groups of 2. So right here I have 4 groups of 2. So I'm going to take out 2, 2, 2, and 2, multiply those together. That gives me a 16. That's going to leave me with this 2 left over underneath the radical. Then I have a pair of A's, so I get to take 1 out. None are left underneath the radical. Then I have 11 B's. That means I get to take 5 of them out, but 1 of them is left underneath the radical. Now, our index is even. Both of these have odd exponents, so you might think we're going to put the absolute value bar around both of them, but we actually are only going to put it around the A, and I will tell you why. Notice how there's still a B under here. It can't be negative because you're not allowed to have a negative under there. So since this can't be negative, that means that none of those could have been negative either. So if you have that odd exponent, but you still have another one of those variables underneath that even index, you also do not need to worry about the absolute value bar. Okay, so number 10, I'm just going to take this denominator and rewrite it in the form of a radical with an index of 3. All right, so let's look at what we have. This has a coefficient of a 9. This doesn't have a coefficient at all. It's kind of like there's an understood 1 there, so 9 divided by 1 is 9. Now let's look underneath the radicals because I can divide those. 48 divided by 2 is 24. X to the 8th divided by x cubed. Keep the base, subtract your exponent, and you get x to the 5th. Let's talk about 24. 24 is going to break down into 3 times 2 times 2 times 2. I'm looking for pairs. So I get to take out a 2. I'm going to multiply it times the 9 that's already there. That's going to make that an 18. Then I have x to the 5th power. I get to take 2 of them out. But, oh, wait. You know what? I totally forgot that the index is a 3. Okay, womp womp. Let's go back. Your teacher goofed. Sorry, y'all. Let me rewrite this with an index of 3. See, this is what happens when you don't pay attention and you're tired. All right, now we're talking. We got a group of 2's. So I get to take that 2 out. I'm going to multiply it times the 9 that's already there. It's going to turn into an 18. That means that underneath the radical with an index of 3, I am left over with that 3. Then I have x to the 5th power, which means I can take 1 out, but there's going to be 2 left over. And I don't need to worry about absolute value bars because of the fact that the index is odd. Now real quick, let me just show you, going back here, if you look at the directions, it said simplify each expression, which we did. And then the directions say, and I purposely ignored the second part because I wanted to go back. It says assume that the value of each variable is positive. When you get to these type of problems in your homework, and your book says assume that the value of each variable is positive, that means you don't need to worry about those absolute value bars at all, because we're assuming that everything is positive. But the reason that I did not do that on those examples is because I felt like we needed some more practice with understanding when you do need the absolute value bar versus when you don't. But when you see this in the homework and you're checking your homework answers in the back of the book and you don't see absolute value bars, this is why, because it says assume the value of each variable is positive. So you might have some problems that you have to do where you have to think about, do I need an absolute value bar? And you might have some problems where you don't need to worry about it at all. So just pay attention to what the directions are telling you. Okay, so radical expressions, it says that you can add or subtract them if two things have to be true. Their index has to be the same and the radicand has to be the same. Remember, radicand is a big word for what's underneath the radical. So let's look at number 11. So we are adding what's in this parentheses to what's in this parentheses. And these two do have the same index, but they don't have the same radicand. However, we're going to break that down because 12 breaks down into 2 times 2 times 3. So I get to take out a 2 and I'm left with the square root of 3. And then I'm going to break down the square root of 75 because 75 is 3 times 5 times 5. That means I have a pair of 5s. 5s comes out, and I said 5s, I meant 5. 5 comes out, and then I'm left with the square root of 3. So that now makes these two like terms. Their radicals have the same index of 2, and their radicands are both 3. So I'm going to combine like terms. I like to start with my integers first. So 6 plus negative 7 is negative 1. Then I'm going to add these radicals together. Now when you add radicals, your radical itself doesn't change. The index doesn't change and the radicand doesn't change. The only thing that changes is your coefficient. So 2 plus 5 is 7, and then you keep your square root of 3. Pretty easy. All right, number 12. I'm going to caution you. There's a minus sign there. And I tell you guys this all the time, and some of you are still struggling to remember it, especially on the last test that I was grading. One of the comments I had to email several times was, forgot to distribute the minus sign, forgot to distribute the minus sign. So I'm going to tell you right now, let's go ahead and do that so we don't have to worry about it later. So this is now going to turn into plus a positive 2 minus the square root of 20. If you will go ahead and do that at the beginning, then you don't have to worry about it later on. So 45 breaks down into 5, 3, and 3. So I'm going to have 8 minus 3 on the square root of 5 plus 2 minus 20 breaks down into 2 times 2 times 5. So minus 2 on the square root of 5. So let's start with the integers. 8 plus 2 is 10. Now I'm going to look at the radicals. I have a negative 3 on the square root of 5 and a negative 2 on the square root of 5. I can only combine their coefficients. Negative 3 and negative 2 turns into negative 5, and I keep my square root of 5 the same because they're like terms. All right, almost done. A couple more examples. Number 13, not adding or subtracting. As a matter of fact, the directions say simplify each product. That means multiplication, and hopefully you guys know that that means we're going to FOIL. First, outer, inner, last. So I'm going to do first, negative 3 times positive 4 is negative 12. Then I'm going to do outer, so I'm multiplying negative 3 and a 2 on the square root of 2. Now notice those aren't like terms, but that's okay because we're not adding or subtracting. When I multiply those, this integer only gets to multiply with that coefficient because they're both not underneath a radical. So that turns into negative 6 on the square root of 2. Then I'm going to do inner. Again, the 4 is only going to multiply times the 5 because those numbers are not underneath the radical. So I'm going to have plus 20 on the square root of 2. And then we're gonna do last. I'm gonna kind of walk you through this one over here off to the side for just a moment, because there's a couple ways you can look at this. So the 5 is going to multiply by that 2 because they're both outside of the radical. So 5 times 2 is 10. These, when you multiply them, those numbers are both underneath the radical. So I multiply them, that turns into the square root of 4. We know that the square root of 4 is a perfect square. That turns into 2. So that whole value right there turns into a positive 20. Now there's another way that you can look at this. Square root of 2 times the square root of 2, that's a pair of 2's. That means the 2 gets to come out. So we had a 5 and a 2 already out. Then we had a pair of 2's. That means another 2 gets to come out, which also gives you that answer of 20. So whichever way you want to look at that is okay. Now we're going to combine like terms. So I'm going to start with the integers. Negative 12 plus 20 is positive 8. Then I'm going to look at the radicals. Negative 6 plus 20 is positive 14, and I have to keep the square root of 2. All right, so number 14, we're going to do the same thing. We're going to FOIL. So we're going to start with first, we're going to get negative 20 on the square root of 6. Then we're going to do outer. So let's talk our way through this because we're multiplying, oops, sorry, y'all. We're multiplying negative 4 on the square root of 6 times negative 3 on the square root of 6. Negative 4 times negative 3 is positive 12. The square root of 6 times the square root of 6 turns into the square root of 36, which is a perfect square. It is 6, and those things multiplied together are going to give us a positive 72. Now we're going to do inner. 1 times 5 is 5, and then we're going to do last. 1 times negative 3 on the square root of 6 is negative 3 on the square root of 6. Again, I'm going to start with my integers. So 72 plus 5 is 77. And now I'm going to combine the radicals. So a negative 20 and a negative 3 gives me a negative 23 onto the square root of 6. Man, I am just breaking lots of lead tonight. Okay, so last thing, we actually have done this in Algebra 1, but it's been a while. It's called rationalizing the denominator. So your final answers are never allowed to have a radical in the bottom. In number 15, I have a radical in the bottom. Well, how can I make that 3 come out? The only way that it can come out is if I have a pair of 3's, which I currently do not. So what I'm going to do is I'm going to give the denominator by multiplication another 3 under a radical so that I have a pair. But whatever you do to the denominator, you have to do to the top. So this is called rationalizing the denominator. We're going to multiply both the top and the bottom by the square root of 3. So that in our denominator, we now have a pair of 3's, which means 3 gets to come out. No more radical, which was the goal. And then in the numerator, we're going to multiply. 1 times the square root of 3 is just the square root of 3. And that is your final answer. The question I usually get is, can I reduce that 3 over 3? And the answer is no. One of those numbers is under radical, the other one is not. Now for example, if you had, let's say 6 on the square root of 5 divided by 2, could we reduce that? Absolutely, because the 6 and the 2 are both outside of a radical. So that could reduce to 3 onto the square root of 5. But as far as these go, no, because that's under radical and that one is not. Now number 16 is different. What's different about it is that there is a plus sign there. So it is not as easy as number 15. It's not hard, it's just going to take a little bit more work. We have to rationalize the denominator, and what that means is that we are going to multiply by the conjugate. Now we learned about conjugate previously when we dealt with imaginary numbers, and so you might be asking yourself, what's a conjugate? I don't remember. Well, a conjugate is the same thing as what you had, but you're changing your operation in the middle. So in our denominator, we have 1 plus the square root of 3. What's the opposite of plus? Minus. So we're going to be multiplying by 1 minus the square root of 3. That's what a conjugate is. It's the same, but the operation in the middle is the opposite of what you had. Now, if I'm going to do that to the denominator, I also have to do it to the the numerator. So I have to multiply the top and the bottom both by the conjugate. Conjugate just changed the sign in the middle. All right, I'm going to work in the denominator first, and you might have guessed this, but we're going to have to FOIL, which is kind of why we practiced FOIL a minute ago. So let's start with first. 1 times 1 is 1. Now let's do outer. 1 times negative square root of 3 is negative square root of 3. Inner, square root of 3 times 1 is square root of 3. And then last, square root of 3 times negative square root of 3. Well, that would be negative square root of 9, and 9 is a perfect square, and that turns into a negative 3. Now what's going to happen to the outer and the inner? They're going to cancel each other out, which is the reason why you multiply by the conjugate. Because what it does, if you successfully FOIL, is it is going to get rid of your radicals. That is the purpose of multiplying by a conjugate, because we're not allowed to have radicals. So what that gives us is a denominator right now of negative 2. Now in the top, right now I have 2 onto 1 minus the square root of 3. I like to wait until I finalize the denominator, because sometimes at this point you can reduce. Sometimes you can't, and then you can distribute that number. In this case, we're lucky because we can, because these numbers we can reduce. 2 divided by negative 2 is going to give us a negative 1 that we would then distribute to the 1 minus the square root of 3. So again, 2 divided by negative 2, that's where I'm getting that negative 1. I didn't write the 1, it's understood to be there. And now the last thing that I'm going to do is just distribute that negative. So I have negative 1 plus the square root of 3, and that's my final answer for number 16. All right, so hopefully you're watching this video on Monday and you're working out some problems. What I have written down on RenWeb under lesson plans, under your homework, and your homework assignment are odd problems, because I really want you to check your answers, is that you guys need to let me know if you would like for us to have a Zoom session on Tuesday. So, and it would be optional. So if you are doing homework Monday and you're really struggling and you're not getting the answers that the back of the book says that you should get, you guys need to let me know on Monday. Don't wait until Tuesday to let me know. Shoot me an email. Let me know, hey, I really want to have a Zoom session, and I will set it up for our normal class time on Tuesday. But if no one tells me anything, if no one emails me, then I am not planning to have a Zoom session on Tuesday. So if you are confused, stressed, needing help, then you need to let me know. Otherwise, not planning one. And so for the couple days, we're going to be doing work on that section, and we won't be learning another section until Thursday. So there'll be another video up on Thursday. So let me know how you're feeling about these problems, and I look forward to seeing you guys in the next video. Bye.